Good morning, good afternoon, or good evening, depending upon where you live around the world. Here's going to be a trial run at a quite thorough, from the beginning, example of drawing the domes, the two style of domes. I do this as much for my exercising my technique as for your perhaps following of what I'm doing. First of all, we start out creating our three legs of our base model. We go out 1 meter by 1 meter in the three axes. And the third one. And what I'm going to do is to save those as a group. For no other reason than when we go to draw some of the other parts of the dome, we don't want these interfering and sometimes sticking to the other components. Then we could create an arc, in this case with 4 sides, from that point here to here. And in the red axis from there to there, and the green axis from here to here. And I'm going to do this bottom one again, because what I didn't see, and it may have been there but I didn't see it, was the point, like see how the green end point indicate, see here it's not showing up here. You've got to make sure that what you've got is being represented on screen, otherwise there's no guarantee that your drawing will be accurate. It seems to be, and I will accept that now as acceptable. I'll group these 3 arcs and then combine it with the other axes, so again they don't interfere with each other. This form is going to be the base for both domes, but it's in the manner in which it is drawn from, or the lines taken from this. So we'll save a copy and we'll just move it back, say 5 meters. Gets it right out of the way. The conventional method is the triangle method, where we create a triangle that touches on all 3 of those points. Make a group, so again they don't interfere or they don't restrict some of the other lines. From there we divide this line into 4. So click into the group, select that, choose divide edges, actually, or divide rather, and we make sure it's 4. We can look down in the bottom right hand corner saying it's 4 segments, and click. Ditto for this line, choose to divide 4 into 4, there we go, and here again 4. Now we can draw our lines that create the triangles. Tell you what, I'll undo that and click out of it. Now I'll draw the lines. We've got our first part of that work done. Come here and down to here and back up here. I'll hide this, and now I can save that as a group. Now we can draw the porcupine, the lines that create the rays. So that'll be, and we'll double up, we'll put one along the bottom, even though that we've got a drawing of a line as drawn here earlier, but we'll put another line in because we may want to save all of the rays, and you'll see later that it's better to have those individual rays rather than part of the drawing. Now here we can choose to draw 1 meter long lines in all these intersections. One way, of course, is to hit the rotation tool and copy it, rotation, copying each time, and keep on doing that so that we wind up with all the rays that we require for the porcupine. Here again, I'm going to hide these items, and now we've got these 5 lines. I'm going to group, but when we rotate it, we only really need to rotate these 3 when we do the base and the other side, because otherwise you'd be doubling up. I'll go ahead and do that. I'll pause it for now and come back as soon as I've done it. And I've done that, and we'll take a quick little look at this because it shows the difference that we will have in this model. Once we get to it, you can see by dividing a line that runs from point to point that the line of intersection, or the line of the ray, is much further uphill than the equally sized segments of the dome. This, I think, is the preferred version because they keep those struts the same length, but of course there are other compromises that will come as we develop this second method that needs to be taken care of. But at this stage we've got the porcupines of the 3 sides. We haven't done the internal ones yet. I'll just hide those. So we've got those right. Well, we can hide those as well. We've got those ones there. 3 bottom ones, 3 side, and the 3 for each of the axes. I'll go ahead now and draw the other parts of the porcupine, the line array, and I'll come back again. You can see in this instance, for this particular dome, there are only 3 internal rays of the porcupine, which creates a surface onto itself, and then this surface will itself be truncated when we go to do the 2 flush and plane sides. So I'll just unhide everything. I've saved, or will save, these as a group, and then I'll add those to the total porcupine or line array. I suggest if anyone's doing these sorts of exercises that they save a separate file that is clearly marked so you can find it when you go back for it, as the template for this particular dome. Do the same when you come to this. Perhaps keep them on the same file so that you can access them, and then you don't have to redraw them. But I'm doing this now for my own satisfaction, and perhaps for someone that's coming to it and they didn't want to listen to all my waffling previously, they can see how it's done. Now I'll bring everything back up just now, but because this sometimes helps you visualize where the lines are, because when they just sit in space they can be quite difficult. So I'll go ahead, and all I have to do now is join the points to make the surfaces. The very top triangle that we have is what I keep on referring to as the squished pyramid, because when you rotate it round to make the four sides, it is a very much flattened pyramid. And of course we just keep on building up the model until such time as we have all the surfaces. Now when you're doing this, you can limit the amount of surfaces or the number of surfaces that you create if you're only wanting to create the pergola or carport type structure. So you don't have to add these lower ones, they're effectively redundant, but you've got the base upon which you can, should you choose, create those other surfaces. So I'll just quickly go through here. You don't always have to group them as you're going, because you will be able to simply select them once you're done, double click and make them as a group. Don't do that, just double click, otherwise you select everything that's attached to it if you triple click. So double click, make group, double click and make group. Have I done all of them now? Yes, it looks like it. They're all grouped. Generally you can tell between an ungrouped group or set of components or parts, because the lines are thinner. When they're grouped, they have a heavier line. Okay, so that's the base upon which this version, the conventional version, is drawn. I will pause now and draw the unit set, or the parts are here, and then I'll come back to you. I'll just organise myself, basically, is what I'm saying, and I'll just move this out of the way. I'll move that, say 3 meters, and this forward when it wants to move. There. I was going to pause, but I'll carry on this section. It's going to be a little bit longer, but it can be broken down. It'd be great if I could timestamp things, but I don't know how to do that. So the method we use here, same base, but we run lines across the intersecting parts of the segment of the sides to the dome. We can then divide these lines, this one into 2, this one into 3, so you've got 1, 2, 3, and of course 4. Very simple. Here you don't have to divide it, because you know you've got a center line, a center point that shows up by our pale blue dot, but you do need to do this one, divide this one. So we'll do that now. Divide in 3, that's fine, we've done that. And we do the same thing. We draw the porcupine, or the line arrays, out at those points of segmentation. Don't do what I just did then. I clicked. Just hover, type in your distance. It will start doing this. I like deleting them. And now we've got our third, just like in the previous version, we've got our third. Aha. I'm going to, well, here's a sketchy lesson. Be mindful that when you dissect or cross a line, see now it has been divided. It will always be divided, and you really don't want that, because it can play up later on. You'd think not, but having had a little bit of issue So what I'm going to do is make sure, yes, that's all, that's fine. I'll draw my line in again. Doesn't take long. Now I'm going to, for simplicity's sake, group them right now. I'm going to then click back into that grouping and now divide that into 3. And now that, because they are a group, when I draw my lines, I just have to find the spot. It's the end of group, 1 meter. Draw my lines again, and 1 meter. When I click on these lines, they are one single line. They haven't been divided by this line, so that we don't have any problems later on. Draw the third line before I forget, and now I can group them as complete and single lines. We then create our other arrays simply by connecting, and they'll all be 1 meter, 1,000 millimeters. So might as well wait while I do this, because it doesn't take long. And this is the other, what I call the alternate method for creating the dome. Now I'm just going to hide those, and actually no, I won't. I'll undo that, and I'll run my other 3 axes along the model. Hide that. I can hide that, and now I've created the other porcupine. They will sometimes look similar if you're not able to reference it to the intersection points. But what's very, well, I'll take that back. You can tell, because this will be, this strut or this line at this stage is the same length as this. If I just put a line on there, as we see, it's 390 or thereabouts. It's 390, as are all the other parts of the segments around the circumference of the dome or the arches that we've got drawn. Now you can go ahead and create your dome. Now, and what I'm going to do is to group those, because I do not want these interfering later on. So I can just draw along this top 3 points here and make my first surface. Ditto here. And what becomes apparent when you're doing these is how different in size and overall proportion the surfaces are compared to the previous version. So the advantage of having these parts similar or exactly the same size means that our other surfaces and therefore lines are going to be significantly different, which is a bit disappointing, but there you go. So we've saved those 2 surfaces. I will now go through and save these. I'll just pause and come back. And having done that, we can make a direct comparison of the surfaces here and the leg if we wish to do so. It's not necessary at this stage, because we are going to truncate these 2 or these 3 surfaces, 4 you could say, but it makes a significant difference to the shape and the proportion. So if I take, oops, I'll tell you what, I will group them. How's that for an idea? Before I go any further. Ditto here, because I know I haven't done that either. A group, move a copy back, say 5 meters for no other reason than it's an easy number to remember. I'll rotate this around 90 degrees and then multiply that by 3 to give us this group. I do the same thing here, gives us our 1/2 of a dome, or effectively the pergola type structure, and now we can compare them from on top. You can see here that kind of similar, but this one seems to be a bit lumpier than this. There's more indent here than there is here. The legs are a wee bit more gentle here by the looks of it, but at this stage not a huge difference between the two. Certainly seen here a much larger pyramid at the top. That's because the struts are going to be the same size. It makes for a bigger pyramid. Doesn't really look much difference in the, or rather look much different in the two areas that I refer to as the hexagon, but you can see that it's different as the method is. The plan view is not grindingly different. But it does, it changes when we truncate, and it's where we draw the leg, and because of the proportions we truncate, you could say, more of one and not the other, so it has a greater impact. Okay, I'm going to stop it there. This is a longest recording I've made so far. It condenses the two methods onto one video and shows the ease of drawing these two versions of dome, or the two versions to create a dome. Just by actually, while we're looking at it, we just take a front view, and here you can see that the apex of the front is much steeper in the conventionally drawn method than it is here. That's interesting, because I do actually prefer this more gentle angle. From all the photos I've seen, this does seem to give a much more pleasing entrance to the dome, but we know the downside is the length of the strut, and we can see here straight away that this one, the conventionally drawn method, has a much shorter leg, which in itself is a little bit, well, it can be pleasing, and may well mean that that's why there is less of a change to this particular strut, just the way the proportions and positions of that strut is created in the drawings. It's more for my observation than benefit to you, so I will stop here and allow you to go away knowing that if you want to replicate this, you can. These will be made available at some stage once I get organised, but these will be made available if you want to use those as a base upon which you want to draw, and then learn how to do it yourself. But really, what I've just shown is all you need, and as I say, quite easy. Rightio, I'm going to wander off, and I will see you in another video. Okay, bye.